Okay, I just wanted to welcome everybody to our first online lecture. This is what we'll do for the most part, as long as the college is operating on a 100% online basis because of the COVID-19 virus. Most weeks I will upload a video of the lecture, if you will, like this, for you guys to watch. Some weeks we will meet in person online. It's kind of a weird way of putting it. In other words, sometimes we'll have interactive sessions during our regular appointed class times. So you need to check your Canvas page frequently for any updates to the schedule that would reflect that sort of thing. But for this week, you're going to be on your own to do the class assignment stuff and watch the video on your time when you like, and you won't necessarily have to be online tonight during our normal class time. But in the future weeks, there will be some times when we do things during that time period, when I have discussion groups and chat rooms, that sort of kind of things, using some of the Zoom technology where we'll have an opportunity for you to interact and ask questions about things if you have issues. In the meantime, if you have a question or a concern, send me an email. I also went back, there was a few assignments people had missing, and I've extended the deadline on a lot of those until next week. So if you have assignments that you haven't turned in, or assignments that you emailed me thinking that I will grade them and count them, I will not. We don't send assignments or accept assignments via email, so if you have that kind of stuff, check your grade book to see if you have those grades submitted, those assignments submitted, and if not, go back and submit them. Alright, I'm going to talk a little bit about attribute data. There's about 40 slides. This should take about 30 minutes or so to go over, and then once we're done with this, this will be an opportunity to kind of get caught back up, if you will, with some of those late assignments and to work on, some just general practice on things that you don't really, that are sort of a struggle for you so far. Next week we will have a much more in-depth lecture environment this week because we were all getting kind of up to speed on doing this all at once. It's less of a hassle for me because I've done some of this before, but because I have to do it for all the classes this week, that is a bit of a challenge. So anyway, without going on too much further, let's talk about attribute data. GIS tables come in two types: attributes and standalones. Attributes are basically ones that are stored with the special feature class, and standalone is simply a table of data. Excel files, CSVs, that kind of stuff. Tables are just a generic structure of how data is stored in databases. Columns and rows in GIS, columns are called fields and rows are called records. And then feature ID or object ID is this unique identifier that lets the software identify a particular record. We have different ways of storing these files. One of the most common ones is a flat file database management system. Flat file stores data as rows of information in files. It's simple, it's robust, but it's inefficient for search and query. Another system is called a hierarchical database management system. This stores data in tables that have these defined parent-child relationships. In other words, this file nests inside this file kind of a thing. And they're set up that way so that you could put together very specific inputs that would then fall into a certain other category, And it makes structured, predetermined queries very efficient. And we also have relational databases where we store multiple tables and relationships that are defined on an as-needed basis. These are things that can be very flexible. They're good for open-ended stuff. And these relational database management systems are the most common type used in GIS applications. When we join tables, all we're really looking for is a particular field that has the same information. Common field. Doesn't have to have a common name. The names could be different as far as the name of the field. Here we're joining a FIPS field. State underscore FIPS. Okay, what if it was FIPS underscore state on one side and state underscore FIPS on the other side? You know it's the same information. The names are different. That doesn't matter. As long as the data is the same data or the same data type, then you can match up a 15 to a 15 and join the data that way. Multiple joins, more than two tables may be joined to a target table. Two tables with only a state name or state abbreviation field can be joined using a common table. With both fields, the same table must be the target for all multiple joins. A table cannot be both a target table and a join table. Alright, so what does that mean? You can join something to something and then something else to something else, but notice here how we're joining state abbreviations to another field, state abbreviations, and then we're taking that state name and joining that one to another state name. That's how you can do the multiple joins. You couldn't, for example, join two separate files that had state abbreviations to another one with state abbreviation. That wouldn't work. One-to-one joins, they have to take into account cardinality. So when we talk about cardinality, what we're talking about is not north, south, and east and west. It's about one-to-one, one-to-many, many-to-one, and many-to-many. One-to-one is the simplest and easiest to understand. Two data sets, one has a Washington entry, the other has a Washington entry. You just join one-to-one. Many-to-one would be, for example, in this example, you have all these different attributes that are found in Washington, and you want to attach some Washington information to it. So you have the one data set over here on the right, and you're going to join it to the many. So when they say many-to-one, they're talking about one record. It is repeated as many times as possible and joined to the other. I don't like the way that they phrase this, calling it to many-to-one. I look at this as one thing is being joined to many. They in the textbook kind of look at it differently. Okay, they call this a one-to-many joins. I would call it a many-to-one. It just depends on how you look at it. What happens when you try to do this is you're trying to join multiple records to one record. You can't do it. Not without averaging or doing some other kind of calculation, because you can only have one record that goes into the target table. Thus, the things that you're bringing in that are more than one has to be averaged. Sorry about that. This is a situation where they say a relate might actually work better. So rules of joining one-to-one and many-to-one. As long as you're taking one piece of information and adding it to another one piece of information, joining works pretty easy. But when you have many-to-many, multiple things, that kind of stuff, it becomes more complicated. And so here are some of their examples of how this works. Don't get too caught up into the actual phrasing of many-to-many or one-to-one. Just know that as long as you're joining one piece of information to one piece of information, it's not a problem. Even if the one piece of information is joined to multiple pieces of information, it's not a problem. It's only a problem when multiple pieces of information have to be joined to one. When you do a join and there's something missing, you get a null entry. And that's not necessarily a bad thing. It allows you to see what is not in the other data set or what is in the other data set. Joins have this clever little graphic user interface that allows you to go through, select the data sets, look at the fields, and parse it all out. It eliminates errors in typing and spelling. You can also then explore your attribute data and do it statistically. There's lots of things you can look at, like the distribution, the count, the minimum, the maximum, the sum, the mean, the standard deviation. All this will help you understand what's actually going on. And here we look at some earthquake data, and we've got this really skewed data set because we have all these zeros. And turns out we need to take the zeros out. But why? Well, there's a whole bunch of them. If they didn't know what the magnitude was, it is listed as 0. You can also make charts and other things. These are good ways to explore data because you can identify things like outliers or potential outliers. A lot of times they're just, sometimes they're errors, sometimes they're just not expected values. Summary statistics, you pick the table, you pick the field, you tell it what calculation, what statistics you want, and then it does it. When you calculate statistics with a case field, it can be used to group features first. So instead of calculating the sum of the deaths or damages, for example, using state as a case field, it gives you a new table where you have the sum of that particular thing, like damage or deaths, by state. So if you have reports from all these different places, you can group the places together by state so that all the California quakes come together and you get a count and a sum total, and etc. Fields have specific types. When you create them, no more than 13 characters, only use numbers and letters, has to start with a letter. Pick the right type of field when you make it because you can't change it. The only thing you can do is delete it and make another one. Binary data, bits, and whatnot. We're not going to spend a glorious amount of time discussing this. What you need to know is really on one of the next slides. ASCII storage is just a way of storing things as text. Again, an ASCII file is a way of taking this information and sharing it. As far as the storage limits, if it's a 1 byte, your value is between 1 and 255. If it's 2 bytes, it's up to 65,000. 3 bytes, it's up to 16 million. 6 bytes is up to, 4 trillion or something. So understanding that, and then if you have signed integers, the maximum value is cut in half because it goes positive and negative. So instead of 65,000 and change, it's plus or minus 32,000 and change. You see? Integer versus float. If you want whole numbers, you use integers. If you want decimals, you use float. As far as the precision in float, if you use a double precision, basically what you get is a mantissa that's twice as long because floating point operates off of a scientific notation format. And so if you need more significant figures, you use the double precision. Database storage. Different kind of things, integer versus float, ASCII versus binary, bits and bytes and whatever. Remember there's some limitations, like with ASCII files. It's a 10-byte system, and so as far as letters, you can only get part of the word Mississippi in, so you have to think about some of these things when you put this stuff in. Okay, when I said some of the fields that you need to pay attention to, this is one of them. Pro has 6 basic field types, short and long for integers, float and double for decimals, text and date. Here's a list of the fields. There's the explanation of what they're for, and then it gives you some examples of the kind of values and entries that you can have. This is what you need to sort of commit to memory and be willing to look at when you're trying to select what type of field you want to create in an attribute table. There's also geometry fields, things like geodatabase attributes like shape underscore length and shape underscore area. Okay, these fields are automatically updated in the feature shape change. If the feature shape changes during a generalization or dissolve operation, all user-defined geometry fields must be updated manually. What does that mean? Alright, in Pro, we're working in geodatabases with feature classes and features. In that environment, shape underscore length and shape underscore area are automatically updated. If you create an area or length field on your own, something other than those automatically created ones, they're never updated. If you have a shape file, they're never updated. Okay? Always assume that those things are wrong and calculate the attribute geometry using the tool on the field to automatically update it to make sure everything's right. Domains are just rules that we can put in place with a field that can limit the possible entries. This is more for making data entry easier and preventing errors. Here are some examples of different kind of domains. How do you create them? You go in through the areas just like it's saying here. Prices, exercises will walk you through the process better than I can explain it. But generally, these are the kind of things that if you're going to use data sets repeatedly by multiple people, this is a really good way of doing that. And then once you have these things, you can assign the various features about it and whatnot. The schema is a structure of a table, including its fields, its definitions, and its domains. We generally don't deal much with schemas. These are these overarching things that are more about record keeping, if you will, about what things are and how they work. They can be useful for a lot of stuff, but it's not something that we're going to generally go around and create in class. When you look at your table, this just gives you some idea what fields are, records. When you right click, what you see, where your table options are, the status bar, explaining what some of these things are. So whenever you look at prices, tutorials, or work through the stuff in the textbook, if you're not sure what she's talking about, here's some ideas. So what are some of the properties? Like a layers, table views have properties that affect how they're displayed. Some settings are cosmetic and don't affect other things. Some things do. So some common table view settings include things like aliases for field names that makes them more understandable, formatting for fields so you have consistent use of decimals and significant figures, displaying only some of the fields, and so you can go in and select only the fields you want to see in the attribute table, and that makes it a lot easier to work with. You can change the order that they appear. All this is all about making it more user-friendly. The field view is used to view and modify the property of the tables. You can switch between field and data source. And the changes affect the source table are permanent. Be aware of what types of changes are being made to fields when you're using the field view and the data source view. Renaming this white field is a permanent change. So you see there they got it highlighted. If you change it there, it's permanent. So what are some of the cosmetic effects? Display, settings, changing display width, formatting numbers, highlighting a field, changing an alias. What are permanent? Add, deleting a field, changing a field name, changing the defined storage width, creating domains, creating subtypes, changing an alias, in all maps, table views, and projects. How do we edit fields? The pencil. How do we calculate fields? Use a geoprocessing tool called Calculate Fields. It puts together the code in the expression. You select what you want to do via the functions and the fields, and that makes it work a lot faster. Importing Excel data, you can read them in Pro directly. There's certain requirements. First column has to contain the first row must contain the field names. Every column can only have one data type, so you can't have some numbers and some letters. If it's either text, it's text. If it's numbers, etc. No formulas, no blank lines, no merge cells, that kind of stuff. Follow these rules when you set up data in Excel, and you can import it in pretty easily. You can also import text. Here we have tab delimiter and CVS files and fixed columns. Pro cannot read the fixed column format, but Excel can be used to convert fixed column into CVSs.